let vector A equal 7I hat minus 10J hat plus 5K hat, and vector B equal 3I hat minus 2J hat plus 8K hat. Calculate the angle between A and B, the projection of vector B in the direction of vector A, and the projection of vector A in the direction of vector B. So this is a classic dot product problem. To review the vector dot product here, we have vector A dot vector B is equal to A, B, and let me be very clear. We have the magnitude of A times the magnitude of B times cosine theta, where theta is the angle between them. This is often written just AB cosine theta. Okay, and then we can also say that A dot B is equal to AX BX plus AY BY plus AZ BZ. This is a form of the more general definition that is kind of agnostic to the coordinate system that you're in. So you could have 3 coordinates, you could have 2 or 60, whatever you want. But you can see how this would extend into more coordinates or less. Okay, so starting here, we can rearrange this top equation to find the angle theta, pretty straightforward, and substitute this bottom equation into the left-hand side of this top equation. So doing this kind of step by step, we can divide this whole guy right here, this entire equation, by AB, the magnitude of A times the magnitude of B. So we get that the cosine of theta is equal to vector A dot vector B over the magnitudes. Well, vector A dot vector B is this guy right here. I'm just going to plug in right now. We get 7 times 3 plus minus 10 times minus 2 plus 5 times 8 all over. Oh, look at this. We need the magnitudes A and B. Well, the magnitude of A is simply the square root of 7 squared plus 10 squared plus 5 squared. Okay, well, what is this? This is 49 plus 100 plus 25. Well, what is this? And I'm just going to pull out my calculator here. 49 plus 100 plus 25 is 174. I know likely many of you can do that in your head. I chose not to. Similarly, the magnitude of B is going to be 3 squared plus 2 squared plus 8 squared. Okay, what do we have here? We have 9 plus 4 plus 64, and this is equal to what, 77? 77, okay? So we get 174 times 77 right there. Good. Let's go ahead and plug all of this in. I've got a Python session pulled up on my computer in front of me here, so I'm just going to type this in really quick. Let's see, we want... Got to get NumPy ready to go here. So we're going to say we want 21 plus 20 plus 40 divided by np.square root 174 times np.square root 77. Okay, this whole, it looks like this entire quantity here is equal. Did I do that right? So let's see, we got 21, we got 20, we got 40, square root of 174, square root of 77. That's a multiply in the middle there. I've got equals 0.6998. Okay, and now this is the cosine of theta, right? So the arc cosine of theta is going to be, or the inverse cosine of 0.6998 is equal to theta. And in degrees, I can simply do, let me do 0.6998 and then cosine minus 1, or cosine, we get an angle of 45.589 degrees. Okay, so there we go with our angle. There's an answer right there. Okay. Ooh, my writing is not very straight. That's okay. And now we can say, okay, calculate the projection of B in the direction of A. So let's imagine some vectors here. Let's do a set of contrived example. Imagine this is vector B, and this is vector A. Okay, nice and long there. Well, if we were to create a right triangle here where this is the right angle, try that again, where this is the right angle, we call this length right here B projected onto A. Similarly, if the right angle were up here instead, A in the direction of B. But it's the direction of B, it's not B itself. So imagine this guy coming way up here, then you have a right angle. Okay, so let me get rid of that. All right, let's go ahead and calculate these really quick. Hopefully it's well. Let's look at the trigonometry here. This is theta, the angle between B and A. Here we have a hypotenuse, an angle, and an adjacent side. And what we're trying to find is the adjacent side. We know the hypotenuse. Here's B, magnitude of B. We have this cosine. But we know that cosine of theta is equal to the adjacent over the hypotenuse. We're looking for the adjacent, BA over the hypotenuse. B, what does this tell us? This tells us that BA is equal to B cosine theta, where B is the magnitude of vector B, right? Well, let's just go ahead and use this now, and I guess I'll leave my drawing there. Why not? So let's see. It wants B in the direction of A. Okay, so BA. Well, look, we just derived this right here. Is equal to B cosine the angle between them, where B. Ooh, but you know what I didn't do? Oh no, I did. Screw root 77. Root 77 times the cosine of 45.589 degrees. Okay, similarly, A in the direction of B is going to be A times cosine theta, okay, where we can say A is square root of 174 times the cosine 45.589. And there we go. This is our use of the dot product to determine the angle between two vectors, as well as the projections of each of these vectors onto another.